Okay, we're talking about permutations. And permutations, write that up here for you, is where order is important. And an example of where order is important is if you were running a race. You want to know who comes in first, second, third, that type of thing. All right, so with this guy, looking at the word problem here, you've got Abby, Jody, and Vicky. You've got 4 kids or people. They're getting employee of the month, and they want to know how they could print their names. Well, you could run it down: Abby, Joel, Cody, Vicky. Abby, Cody, Vicky, Joel, and then you can go Abby, Vicky, Joel, Cody, and you keep going on and on and on. But if you just want to know the total different ways you can write it, you would do this. There's 4 of them, so you would start with the number 4, and that's going to be this 4, where you have it's going to be 4, and then 4. We want all of the orders. What that means is this: you're going to start with the number 4, and you're going to go all the way multiplying a certain number of times. So in this case, 4, because you have the 4 of them. And then you're going to take 3, 2, and 1, and you're going to go in descending order. So it's going to be 4 times 3 times 2 times 1. So you're going to get 12 times 2 is 24 times 1, so 24. There are 24 different ways to do this. Now, when you see this and you're starting out with like 4 different options and you want every single option all the way down, it's not normally written like that. It'll be written like this: 4 with an exclamation point, and that is a factorial. That's what that's called. That's a pretty cool math term. All right, so we're going to get rid of this, and I'm going to go back to my screen, and we're going to put in our 24. All right, so if Hector's creating a sample to give a producer, he's got 3 songs. How many different orders can the songs be done? You've got 3 times 2 times 1, because you're going to start with the number 3 that you have, number of options, and go in descending order all the way down. So you're going to have 6. All right, and if we jump up a level, let's see. I'm going to go ahead and snip this so I can write on it. And okay. A new cookbook as a gift and wants to try a new recipe every weekend. So here are our choices right here. And how many different orders could he bake those pies? Well, how many pies are there? 1, 2, 3, 4, 5, 6. So you would have 6, and you would go all the way down to 1. So you have 5, 4, 3, 2, 1. And I'm writing these spaces out like that because if I had this 6, 2, that would be something different. And I'll show you what that is. But they just want to know how many pies he can make. So you're going to have, multiplying all these together, well, let's do this. 10, that makes my life easy. 12 times 6. So 12 times 6 is 72. 72 times 10 would be 720. That's the total. But if I only needed that 6, 2, it would be 6, 1, 2, 5, 4. You would get 30 times 4, which would be 120. That's the difference. When they ask all of the possibilities in every single excruciating order, you're going to take the number of choices and multiply it all the way down, times 5 times 4. If they have a comma and a different number after it, that means you only need however many that is. Okay, so we've got, in this case, 720. That's a lot of pies, but let's check it.